All right, what we're going to look at here is the difference of perfect squares. So let me give you a couple examples and we'll kind of look at the pattern. So if I have let me try again. If I have something like x plus 1 times quantity x minus 1, I can FOIL this and write the expression in standard form. So x squared minus x plus x minus 1. I can combine like terms. Minus x plus x is 0, so I'm just left with x squared minus 1. We can look at another simple example, x plus 2 quantity x minus 2. And we can FOIL this, and you get x squared minus 2x plus 2x minus 4. And if we combine like terms, we get x squared. Negative 2x plus 2x is 0, so x squared minus 4. X plus 3 times quantity x minus 3. If we FOIL this, we get x squared minus 3x plus 3x minus 9. Combine like terms, minus 3x plus 3x is 0, so we get x squared minus 9, and so on. So I typed these out below, so if I scroll down, you should start to see this pattern. So x plus 1 times quantity x minus 1, you get x squared minus 1. And as we keep going, you get x squared minus 4, x squared minus 9, minus 16, and minus 25, and so on. And so what you should notice is that the first term here is squared, and the second term is squared, and we're just subtracting whatever the result of that second term squared is. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. And so if you have, we can make a generic rule for this. So if we have a plus b times the quantity a minus b, you end up getting a squared, so the first term squared, minus b squared, the second term squared. So when we're factoring these, if you recognize that you have what's called a difference of squares, so two perfect squares and you're subtracting one from another, when we're factoring, we're going to be going this way. And what you'll be able to recognize is, hey, x squared is a perfect square, 1 is a perfect square, so it must just be x plus 1, or a plus b, and x minus 1. So when we apply this to something maybe a little bit more complex, here, what you need to recognize is you have a difference of perfect squares. So this term is a perfect square. This term is a perfect square. Square root of 25 is 5. Square root of x squared is x. So you have 5x squared minus 4 squared. And so what you'll recognize then is we just take the square root, which is of each term, so 5x and 4. And when factoring, this becomes 5x plus 4 and 5x minus 4. So if this is my a term and this is my b term, it's a plus b, a minus b. And we can check our answer using our calculator. Here I can FOIL it out for you. Either would work, but you would have 25x squared plus 20x minus 20x minus 16. So that plus 20x and minus 20x end up 0, and you get 25x squared minus 16. We'll look at one more because I think this one's a little bit more straightforward than the perfect square trinomials. But here I have a perfect square. Here I have a perfect square. Don't forget 1 is a perfect square. And so this is a difference of perfect squares. And so I can apply my rule. So it's 6x quantity squared minus 1 squared. And so we end up with 6x plus 1 and 6x minus 1, where this is my a plus b, this is my a minus b. So these are a lot easier to recognize. A lot of times when you have just two terms and there's subtraction, just make sure the first thing you should check are these perfect squares? Because if so, you can just apply the difference of squares rules and factor it really quickly.